Good day, folks. Welcome to my YouTube channel. If you are new here, please don't forget to subscribe and like all my videos. Share with your friends and families. This is a graph of an electric circuit. Now, let's cut the chase. Now it says a learner perform an experiment to determine the EMF and internal resistance of the battery using the circuit below. Here's the circuit. The learner use their recorded readings of current and resistance together with an equation. There's an equation. I'll explain that equation obtained from the graph below. Now, this is the circuit. They use the what you call it's the rheostat or the variable resistor, and there's a battery and there's a ammeter there and the switch there. Now guys, if you look at this graph, let me explain a bit about the graph. This graph, guys, it's a direct proportionality between the resistance and the inverse of the current. So as the inverse of the current increases, the resistance of that increases, or as the resistance increases, the current increases. But the current is the inverse, right? The current is an inverse. We know the current and resistance, they have an inverse proportionality. But now, as the resistance increases, the inverse of the current increases, right? Now, guys, let's look at the equation of this graph. Before we go to the question, the equation of this graph, it comes from EMF is equal to I. That equation, that's the definition of the EMF. So now, looking at my y-axis here is the resistance, and my x-axis is the inverse of the current. I'll try to make my y as as the resistance, which is the external resistance there. So I'm going to divide by the current. So I'm going to have here R plus R is equal to E divided by I. And then since my R is my Y here, I'm going to make Y as a subset of the formula. So I'm going to say R is equal to E over I minus R, right? If you look where my graph cuts, it cuts in the resistance. But this resistance here is the internal resistance. And that internal resistance is negative there. But look at what our C. This is our C and this is our Y. But if you look at our X, it's inverse of the current. So that means the E here, if I change that and say minus R, that means here, the E here, okay, this is going to be Y, and your E, which is your EMF, is going to be your gradient, and this is going to be your X. Do you see it's 1 over current? And then minus what? It's going to be plus C. This is your intercept. That's very important, that, guys. That's where the graph comes from, or the equation comes from. This equation, the one that we're given, guys, most of the time they'll give you this equation, right? Now let's answer the question quickly. It says in 14.1, in which variable has to be kept constant in this experiment? It's obvious, it's the temperature, right? You write it in full. Refers to the graph. 14.2, it says write down the value of an internal resistance. As I've mentioned, guys, that this value here where your graph cuts, it's an internal resistance. But now, how do we know how much is the value? What is the value? So if you look from 0 to negative 5, it's the distance there is 5, or the units is 5. But how many lines that are there? These lines are 10 of them, right? There are 10 of them. So in order to know how many single line represent there, we're going to say 5 divided by 10. It's going to be 0.5. That means each and every line there is represented by 0.5. But now, where is this cutting in which line? It's 1, 2, 3, 4, 5, 6. So we'll say 0.5 times 6, which is going to be what? 3. So this simply means that the R there is what? Is 3, right? The R is 3. So we'll say here the answer is what? Is 3 ohms, right? The R there is 3 ohms. That's the answer there. Now in 14.3, which is the last question there, right? Calculate the EMF there. So I'm going to take this point. This point, guys, it's 1.5 is 2. What is this point here? So that's 5. It's going to be 5.5, 6, 5.5, 6, 6.5, 7, 7.5. So it's 2, 7.5. And then which are the point that I'm going to take? I'm going to take this point. Let's take this one. This one is going to be, do I need more? I don't need more. Okay. I'm going to say 1. This is 1. And is to 4. This is 4, guys, right? This is 4 because it's 5. It's 4.5 and it's 4. So that's 4. The EMF here is the gradient, guys, here. As I've mentioned here, if you look here, the EMF is the gradient, right? So what are we going to do? I'm going to do it in 2 ways quickly. I'm going to use the equation, which I'm going to say R is equal to EMF times 1 over I minus R. So I'm going to substitute these points, right? So this points here, guys, I'm not going to waste time and show you. This point here, it's 1 is to 4, and this point here, it's 1.5 is to 7.5. Guys, these points are just those are the points there. This is the point and this is the point there. So I'm gonna use this one, right? Using that one, I'm gonna substitute my y. My y is 7.5, and then E, that's what I want. And then remember, this is 1 over I. It's 1 over I. So this 1.5, this 1.5 is already 1 over I. So I'll say 1.5 there minus, and remember the internal resistance there is what? Is 3. So I'll substitute 3 there. So if I take 3 to that side, so it's going to be 10 is as equal to 1.5 EMF and divide by 1.5 and divide by 1.5. So the EMF there, so 10 divided by 1.5 is going to be 10 divided by 1.5, it's going to be something that is almost to 7. It's going to be 7 volts, right? Guys, I hope that makes sense. Let me show you another way of doing that. Doing that, guys, it's I'll use the gradient now. I'll use the gradient, so I'll say I'll use the gradient, which is the gradient is change in y over change in x. What is my, I'll take those 2 points. I'll say 7.5 minus 4 divided by, that's minus 4, yeah. And then it's going to be 1.5 minus 1. So if I punch that in the calculator, it's 7.5 minus 4 divided by 1.5 minus 1. The answer is 7. Guys, the answer here it was 6.67, which is when you round off that into the nearest whole number, it's going to be 7, right? It's going to be 7. Okay, now we got the 7 there, and we can use even any other point there. It will give us 7, guys. So I think that's it. Thank you. Cheers. Bye.